Element 6, Fire Safety. 1. Explain using a suitable sketch, the significance of a fire triangle. Fuel. Any combustible material or substance. Oxygen. Consumed during combustion when it is chemically combined with the fuel. Heat. A heat or ignition source is essential to start the combustion process. 2. Identify 4 methods of heat transfer and explain how each can cause the spread of fire. Conduction. Where heat is transferred through a conducting material, for example, metal, without the conductor itself is burning. Convection. As the hot air and gases rise from the fire, cooler air is drawn in which, in turn, is heated and rises. The continuous process of air being drawn in and heated, then rising, cooling and descending, forms circulating currents which enable the fire to spread. Radiation. Heat energy from the fire, in the form of infrared radiation, is transmitted through the air and may be absorbed by other fuel sources, causing them to heat up, possibly enough to cause ignition. Direct burning. Combustible materials in direct contact with naked flame. Outline measures that should be taken to minimize the risk of fire from electrical equipment. Measures such as the proper selection of equipment to ensure its suitability for the task, pre-use inspection by the use, establishing correct fuse ratings, ensuring circuits and sockets are not overloaded, disconnecting or isolating the equipment when it is not in use, and ensuring that electric motors do not overheat, for example by checking that vents are uncovered. Additional measures include the need to uncoil cables, particularly extension leads, to prevent the buildup of heat and protecting cables from mechanical damage. Importantly, electrical equipment and systems should be subject to regular inspection, testing and maintenance by competent persons. This should ensure, for instance, that contacts are sound, thereby reducing the likelihood of electrical arcing. 4. List 8 ways of reducing the risk of a fire starting in a workplace. Flammable materials are removed from the work area. Items that cannot be removed are covered with fire retardant blankets. The floor is swept clean. Any wooden floor is damped down. A suitable fire extinguisher is at hand. A fire watcher is present in the area. The work area is visited routinely after the work has finished to check the area for smoldering. Ensure that workplace is well ventilated. Store and use required minimum volume only. Use away from heat and ignition sources. 5. List the 5 steps in doing an assessment on fire risks. Identify the fire hazards, sources of fuel, ignition, oxygen. Identify the people who might be harmed, people in the premises and special consideration to vulnerable people. Identify and implement the fire precautions that are required. Fire prevention. Prevention of the spread of smoke and flames. Fire detection and alarm. Means of escape. Sign and notice. Lighting. Record findings, plan and train. Review and revise the assessment as necessary. 6. Outline the requirement to ensure the safe evacuation of persons from a building in the event of a fire. The means of raising the alarm. An acceptable distance to the nearest available exit. Escape routes of sufficient width. Clear signing of escape routes. The provision of emergency lighting. Escape routes kept clear of obstructions with the fire door closed to prevent the spread of smoke. The provision of firefighting equipment. The appointment of fire marshals. Procedures for the evacuation of those with a physical impairment. The need to practice the evacuation plant at regular intervals. 7. Outline the general duties of a fire marshal in case of an emergency evacuation in a workplace in the event of a fire. Fire marshal might be required to check all areas in the building to ensure that everyone knows that evacuation is in progress and to help where necessary. Give special assistance to the disabled and infirm. Fire marshal is responsible for coordinating the fire evacuation plan. He should organize fire instruction, training, drills and coordinates the evacuation at the time of the fire. He should be made known to workers and they should clearly identifiable at the time of emergency. Fire marshal appointment contributes employer's commitment. He is the vocal point to assist authorities. By appointing fire marshal, the employer fulfills the legislation requirements. 8. Identify the classification of fires and the associated fuel sources. Class A-solid materials, usually organic, such as paper, wood, coal and textiles. Class B-flammable liquids, such as petrol, oil and solvents. Class C-gases, such as methane, propane and acetylene. Class D-metals such as aluminium or magnesium. Class K-high temperature fat and oils such cooking fat fire. 9. Identify 8 common causes of fires in the workplace. Careless actions and accidents. Discarded lighted cigarette end or match. Smoldering waste. Poor electrical connections. Overloading electric circuits and using fuse rates too high a rating. Failure to report and repair faulty equipment promptly. Defective machinery or equipment. Deliberate ignition. 10. With respect to the design features of a building. A. Identify 2 types of emergency warning systems that can be installed in the building to help ensure that all workers can be made aware of the need to evacuate the building. 2. Interlinked smoke alarms. Automatic fire alarms. Smoke detectors. Heat detectors. Hazard warning lights. B. Outline 6 structural measures that can help to prevent the spread of fire and smoke. 6. Compartmentation. The above scenario is obviously not desirable. If fire prevention does not work and a fire does start in a building, then it should be contained and prevented from spreading. This can be done by designing the building in such a way that it is divided up into separate compartments, each surrounded by fire-resistant materials that can resist the spread of smoke and flame. This compartmentation is done at the initial design and build stage but may also have to be done if a building is changed or modified. This is normally a heavily legislated issue subject to strict control and local standards. Common building materials. Fire affects different building materials in different ways. The use of building materials, therefore, has to be tightly controlled to ensure that appropriate materials are used in a structure. For example, fire compartments must be robust enough to withstand the spread of fire for their design time, and structural elements in a building should not fail quickly when they are heated in a fire. There will be local regulation and standards to ensure fire safety. Concrete is usually very resistant to fire. Does not collapse catastrophically. May spall, throw off small chunks. Steel is severely affected by high temperatures. Expansion may occur, pushing structural elements apart. Steel may also twist and warp. Can lead to catastrophic building collapse. Brick is usually very resistant to fire. Bricks are made by exposure to very high temperatures in a kiln. Timber, thin timber, such as floorboards, will burn, but thick timber, such as structural beams, will not usually burn in a building fire. A layer on the outside of the timber will char and protect the inner core. Thick timber is unlikely to fail suddenly, but will do so slowly. Insulation, such as wall insulation, can be combustible, so fire retardant versions must be used. Wall coverings, such as paint and wallpaper, can make a difference to the way fire spreads across surfaces, so should also be closely controlled. Protection of openings and voids. We have already noted that fire doors are used to ensure that door openings are protected in the event of fire. However, buildings, and the fire compartments that they are made up of, will inevitably have numerous voids and openings running through them, such as lift shafts, service conduits, air handling ducts, voids between floors, roof voids, etc. And all these need to be protected to ensure that smoke and flame cannot easily travel from one compartment to another.